Hello students, welcome back. In this video, I'm going to solve questions from isomerism topic. The first question is based on the stereocenters. You are supposed to calculate the number of stereocenters from the given antibiotic molecule. Although this looks complex, it's actually quite easy. All you have to do is identify the chiral carbons because in this case, the stereocenter is a carbon which is attached to 4 different groups. So you can see here from this part, we don't have any chiral carbon. Let's analyze this part of the molecule. You see there is a double bond. So you can ignore this. There are 2 hydrogen. So oxygen, this cannot be the chiral center. Look at this carbon attached to nitrogen, oxygen, and there is a carbon here and hydrogen. So we do have a chiral carbon here. This is the first chiral carbon. What about here? The carbon attached to an amide, oxygen, nitrogen and carbon. So the second chiral carbon. sp2 hybridized you can ignore. And here you see this is also a chiral carbon. Although both of them are attached to CO, still we consider it as a chiral carbon because here you have an amide and here we have a carboxylic acid. Here there is a phenyl group and the fourth atom here is hydrogen. So all put together, how many chiral carbons are there? 3. Hence, the correct option is option B. The next question is based on structural isomers. There are different pairs of molecules given and the relationship is also given. You have to identify whether it is true or false and then choose the correct option. The first molecule is carboxylic acid and the second molecule, if you don't understand what is the functional group, you just elaborate this and then you will know that it is an ester. And what is the relationship between an acid and ester? They are functional isomers. Hence, it is true. Generally, in these cases, the molecular formula given will be same. Okay, you don't have to verify it and waste your time. Now, the second set of molecules are ethers. These two have same molecular formula, same functional group, but the groups attached to the functional group are different. Hence, they are metamers. So, this is also true statement. Just verify from the options where do we have true and true in option C. Therefore, the correct answer is C. However, you can solve for the rest of the molecule. So, here we have an alcohol and here ether. They have the same molecular formula but different functional group. Therefore, they are functional isomers but not metamers. Hence, it is false. Last set of molecules are functional isomers because the given amine here is a tertiary amine as nitrogen is attached to 3 carbons. What about here? It is a secondary. And what is the relationship between secondary and tertiary amine? They are functional isomers. Hence, it is true. Therefore, the final answer is option C. The next question is based on geometrical isomerism. You have to identify the compound which will not show geometrical isomerism and all of them are cyclic molecules. So I'm going to explain this quickly how to identify whether these cyclic molecules will exhibit geometrical isomerism or not. So I have taken cyclopropane, cyclobutane, cyclopentane and cyclohexane. The principle is applicable for all the molecules. What I meant is take the carbon, right? It should be attached to 2 different groups. Like this, you have to have at least 2 carbons. Say here, A and B, A and B. If the identical groups are on the same side, cis, otherwise it's going to be trans. Even if this carbon also has 2 different groups, it's still applicable. So make sure that the carbon must be attached to 2 different groups. And like that, you have to have at least 2 carbons. What I meant is, say if you have a carbon attached to A and B, will this obey the geometrical isomerism? No, not possible. Say if it is attached to A and C, is this allowed? Yes, this is very much allowed because with respect to A, you can still say whether it is cis or trans. Say if it is having A and B here, still this is possible. Similarly, you can do it for the other molecules. Say if this is AB and this is AB, still you can call this as cis. Same here also. Say C and D, C and A. Right? So with respect to this, you can still say it exhibits cis. So you just have to identify whether these groups are present on the molecule or not. Say in this case, the carbon, right, it is attached to A and A. And here it is attached to B and B. Will this exhibit? No, not possible. Hence, this itself is the correct answer. This molecule cannot exhibit geometrical isomerism as the group attached to the carbon are same. Now let's check for this. Yes, this is very much possible. So you can even visualize it like this, right? The methyl groups either on the same or opposite. So it does exhibit. What about here? All the four methyl groups can be cis or trans. It doesn't matter. So it will exhibit geometrical isomerism. So similarly, this is exactly like how I have shown here. So this also exhibits geometrical isomerism. The molecule which cannot exhibit is as shown in option A. This question you have to find out the total number of structural isomers for the formula C4H11N. The first thing you do is calculate the degree of unsaturation using the formula 2C plus 2 minus H plus N divided by 2, where C is the number of carbons. So it will become 2 multiplied by 4 would be 8 plus 2. How many hydrogens do we have? 11 plus 1 nitrogen divided by 2. So upon solving this, what do you get? 0. That means what? There is no double bond or ring possible for this molecular formula. So since the degree of unsaturation is 0, you have to draw different saturated molecules and exclude the optical isomers. So how to do that? First, you write down primary amines because there is a nitrogen as a heteroatom here and there are 4 carbons. So what all molecules you can write here? 1 butanamine and 2 butanamine, isobutyl amine and tertiary butyl amine, like this. Students, remember this whenever we have alcohol or halogen or NH2. These 4 molecules will be common whenever there are 4 carbons in the molecule. This is very, very important. What is the possibility as a secondary amine? So when you have secondary amine, you have to have 2 carbons, right? Like 1 here, 1 here. So I have taken 3 carbons here, 1 carbon here. So this becomes a secondary amine. So whenever you have N-propyl, always make sure that you are going to write the isopropyl like this, right? So there is a methyl here. And is there any other possibility with secondary amine? I think there is one more possibility like this. Ethyl and ethyl, isn't it? So you got one more molecule. Let's do for tertiary amine. So when you have tertiary amine, methyl, methyl, ethyl. Is there any other possibility here? I don't think so. That's it. So count the number of molecules. How many you got? 8. Hence the correct option is option B. Students, I would like to give you one more tip here. Whenever you're supposed to find out the structural isomers for the molecules, always use the bond line structures because it's quite simple when you do it from the bond line structure. If you do the complete structure, it's very time consuming and confusing as well. In this question, you have to identify the pair of diastereomers. What are diastereomers? They are non-superimposable, non-mirror images with the same molecular formula and bond connectivity. Will this definition apply for the first set of molecules? Yes, because the bond connectivity is same and you see that chlorine is above and chlorine is below here. And in this case, both of them are above. They are neither superimposable nor mirror images. Hence, these are diastereomers. There are different ways of identifying diastereomers. The other way is to check the configuration of the chiral carbon. And if the relationship between the molecules is RR to RS or SR, then you can consider them as diastereomers. It's similarly applicable for the other configurations as well. So however, in this case, it's very easy to compare their mirror images and tell whether they are diastereomers or not. Let's check for the B molecules. What is the relationship between these two molecules? You see that the molecule is being flipped. When the molecule is flipped in this direction, the chlorine goes below. And what about here? This comes above the plane. So just by flipping the molecule, you can't change the configuration, isn't it? So they are homomers. That means they are exactly same molecule, just their representation is different. Again, you can do R and S configuration to prove this. If this carbon is, say, this gets higher priority and then this and then this. So when you move from 1 to 3, so this becomes R because hydrogen is below the plane. And what about this one? Chlorine first, double bond second, and this is third. And it goes in anti-clockwise. So it's supposed to be yes, but hydrogen is above. The lower priority group, when it is above S, will become R. So what is the configuration here? R means it's exactly same molecule. It's just the way you look at the molecule is different. That's why this cannot be either enantiomer and also the diastereomer. So you can eliminate this. What about this molecule? This molecule here, you see there is a double bond attached to 2-methyl and double bond is not attached to 2-methyl. So they are not stereoisomers. So you can eliminate this. What about here? You can see they are mirror images, right? So therefore these are enantiomers. So the first set of molecules are diastereomers. These are homomers or identical molecules. These are structural isomers and these are enantiomers. This is the additional information which is much needed for your exam. Thank you for watching this video and don't forget to solve the questions included here and please do comment the answers to verify. Thank you.